So this question we are having, which says that we need to, we are given greatest integer x and we need to evaluate this limit. Okay. So firstly we are going to, we know that this thing is changing 1, 2, 3 till n. So let us consider a variable n and represent it in a summation form. Okay. So let's see how it is going to benefit us. Okay, so I wrote it in the summation form where r is varying from 1 to n. And then I used one property which is that we can write greatest integer x as x minus fractional part of x. Okay, so if we multiply any integer with it, the property is going to remain same. So I applied this with rx. Since we know r is an integer only because it's 1, 2, 3 until n. So then I split it, applied the property, and then we know that summation of r, since x is constant, only r is varying in this. So I'll take x out, and we just need to consider the summation of r, which is equal to this. Okay. Okay, then I'm going to write further ahead. This was just the calculation part. Okay. So now I'm going to write this here. I'm going to split the limits infinity upon n square, and then okay, I can take x also here, so it won't matter. Okay, then I can write it as x into n plus 1 upon 2. So this is our first limit, and then we are going to write our second limit, which is limit n tends to infinity 1 upon n square into fractional summation of r from 1 till n fractional part of rx. Okay. So we know that this quantity is going to be very small since fractional part is from 0 to 1 only. So whatever summation we'll be having summation of fractional part till n. And we know that the summation is also going to be very less because this is very less. And we are multiplying it with a very large quantity, which is where n is tending to infinity. So since this is very large quantity, so this whole limit is going to tend to 0. Okay. So we can neglect it and we can work upon this limit. So our question has reduced. So since we can take x outside of the limit and we need to solve x upon 2, I'll take outside. And then we are left with limit n tends to infinity n square plus n upon n square. Okay. So I'm going to divide by n square on both numerator and denominator, and let's see what happens. So it is x by 2, limit n tending to infinity, 1 plus 1 upon n upon 1. And we know that since n is tending to infinity, this thing is going to tend to 0. Okay. So this whole thing is going to be equal to x by 2. And this is our answer.